Alright, class, this podcast has to do with Hess's Law. And Hess's Law is simply a way of calculating delta H's for reactions that are difficult to measure. So it might be that they give off just a very small amount of heat. It might be that the reactants or products are very dangerous. It might be that it either takes a really long time to give off the heat, so it's impractical to measure them. So what Hess's Law says is, if there's a reaction we want to know the delta H of, if we can find other reactions that can add up to that reaction, it really says the sum of the reactions equals the overall reaction. So it doesn't matter what pathway we take to get there, but the pathway is going to always lead to the total volume, or not total volume, the total amount of heat. Alright? So Hess's Law problems will always be multiple reactions that we know delta H is for. Right? So notice here we have 3 delta H values that we know. And then there's a reaction at the bottom that we want to know the delta H value for. So notice down here, delta H equals we don't know. Alright? So the way that I would set these problems up is, the problems that we know, the delta H's we know, we're just going to label these reactions A, B, and C. Alright? And then we're going to kind of look at our equation that we know, and then identify reactants and products in the equation that we know. So here we have H3BO3, and then in reaction A up here we also have an H3BO3. If we keep on moving, one of our reactants and one we want to know is B2O3, and in reaction C we have a B2O3. And then lastly, we have a water as a product in our reaction that we want to know about. And we have, it's in A, that also happens to be in B as a reactant, and there's some water in C as a product as well. Alright? So kind of look at your overall equation and identify where the reactants and products are in the equation that we're labeling A, B, and C. The next thing we're going to do is we're going to look at coefficients. So again, if we look at our overall equation, we have a coefficient of 2 in front of H3BO3. But up here we have no coefficient, it's just a coefficient of 1. So what's going to end up happening is we're going to want to multiply reaction A by 2. Alright, so we're just going to take this entire reaction and multiply everything by 2. The next thing we're going to look at B2O3, and notice in our overall we only have one B2O3, where in reaction C we have 2 of them. So instead of wanting 2, we really want to multiply all of C by half. Alright? Because we multiply 2 by half, it gives us back to the 1 which we want. Alright, and then lastly, water is kind of just the last thing we're going to worry about. So we're going to start writing these out and kind of see what stuff looks like here in a second. So I'm going to rewrite A down here, and by distributing that 2. So we really have 2 H3BO3s, and they react to form 2 HBO2s, and also 2 waters. And then our reaction C, we're going to rewrite it, and we're going to have half a mole of H2B4O7, and that reacts to form 1 mole, so I'm not going to write anything, of B2O3. And then we also have half a mole of water. Alright, so eventually what we want to happen is all of our equations down here, if we add them up, they should add up to this equation. So notice we have an H2BO4 that's on the reactant side, but we don't have anything H2BO4 related in our overall equation. Alright, that doesn't exist. So we need to get rid of this H2B4O7. So if we look at reaction B up here, notice on reaction B there is an H2B4O7, but it's on the wrong side. It's on the reactant side, and we'd like it to be on the product side so they can cancel each other out. The other thing is we have half a mole down here, we have a full mole up here. So what we're going to do with B is we're going to multiply by negative 1/2. Okay? So again, I'm going to multiply all these by negative 1/2, and when I put a negative here, I'm going to switch my products to reactants and my reactants to products. So I have 4 HBO2s, so I'm going to multiply that by half. Okay, so half of 4 is 2, and I'm going to switch the sides. So I'm going to put 2 HBO2s, and then my arrow and then my two reactants are going to end up on the product side. So I'm going to have half a mole of H2B4O7 as well as half a mole of water. Okay, so lastly what we want to do is we want to add everything up here. If stuff's similar on both sides, we're going to cancel it out and see if when we add this up we get our overall equation. So first of all, we're just going to kind of look at this and see if there's stuff that's similar on both sides. So notice I have half an H2BO4 on the left, and I have half an H2BO4 on the right. So I'm just going to cross those out, because they're going to not end up in my overall equation. Notice I have two HBO2s on the left, and I have two HBO2s on the right. So again, they're going to cancel each other out as well. So what I have left with is, on the reactant side, I have two H3BO3s, and they react to form B2O3, as well as I have 2 moles of water, half a mole of water is 2.5, plus another half is 3 moles of water. So notice this equation matches exactly my equation up here, which is 2 H3BO3s yields B2O3 plus 3 waters. Alright? So these sum to my overall equation. So what that means is up here, what I'm going to do is I am going to, with the mathematical stuff I put here, I'm going to multiply my delta H's by the factor that I listed next to these. So I'm going to multiply 2 times negative 0.02 kilojoules, and I'm going to take negative half times negative 11.3 kilojoules, and then lastly I'm going to take half times 17.5 kilojoules. I can get these answers for each of these. So if I double this, I'm going to get, that's a negative, I'm going to get negative 0.04 kilojoules. If I take negative half of 11.3, the negatives cancel each other out. So we are left with 5.65 kilojoules. And then if we're going to take half of 17.5, that is 8.75 kilojoules. And then what happens is I'm going to simply add all these up. So that's really a negative, but my other two are positives. And when we add all this up, we get 14.00 kilojoules. Alright? So again, all you're doing is looking at, you're going to label the reactions we know, A, B, C, D, or however you would like to label them. Then we're going to look at coefficients, make sure our coefficients match, make sure everything cancels. Once everything cancels and we can confirm that our overall equation is the sum of the equations rearranged somehow, we're going to go back and look what we did with those factors, multiply them by our delta H's, and then add them up. Okay, and that is Hess's law.